So you're planning to build or upgrade your personal AI rig in 2025, and you've got a classic dilemma on your hands. Do you stick with a legendary card like the RTX 3090, which is still an absolute beast and now at a fantastic price? Or do you take that leap into the future with the brand new powerhouse, the RTX 5090?
That's the big question, isn't it? It's on every builder's mind. So today, we're going to break down all the data and give you a really clear, direct answer on which one of these GPUs is the right choice for your projects. Okay, let's dive in.
And you know what? We're not going to make you wait till the end for the answer. Let's just cut to the chase. The RTX 5090 is, without a doubt, the new performance king. It's built for the crazy speed that modern generative AI needs. But the RTX 3090 is still holding its ground as the budget champion, offering just incredible value if you're working on slightly smaller scale projects.
So, how did we get to that conclusion? Well, here's the plan. First, we'll look at the massive generational leap in the tech itself. Then, we'll get into the hard numbers, the specs. After that, we'll see how they stack up in a real-world AI showdown. And finally, we'll talk about the practical stuff, power, price, and size to help you make that final call.
Okay, first things first. To really get why there's such a performance gap, you have to understand the technology under the hood. And this isn't just a minor refresh. We are talking about a major architectural leap forward.
And this timeline really says it all, doesn't it? The RTX 3090, running on that Ampere architecture, came out way back in late 2020. The new RTX 5090, on the Blackwell architecture, landed more than 4 years later. In the world of GPUs, that's basically a lifetime.
So, what's the big secret sauce with these new architectures? Well, it really comes down to one thing: tensor cores. The easiest way to think about these is as dedicated AI engines baked right into the GPU. The RTX 3090 has awesome 3rd-gen tensor cores, but the 5090 has brand spanking new 5th-gen ones. And believe me, that difference is everything.
All right, enough with the theory. Let's quantify that difference. It's time to get into the hard numbers and see how these two actually stack up on paper. Let's start with our baseline, the RTX 3090. It clocks in with a very, very respectable INT8 performance of 284 TOPS. Now, TOPS stands for trillions of operations per second. For years, this number was the gold standard for consumer AI power.
But then the RTX 5090 comes along and just completely rewrites the rulebook. It delivers an absolutely jaw-dropping 3,352 TOPS. The difference is, well, it's just staggering.
Seeing it on a chart like this really puts it into perspective, right? This isn't a small jump. The RTX 5090 has nearly 12 times the raw AI processing power. In the real world, that's the difference between iterating on a model over a long weekend versus getting it done in a single afternoon. It's a huge deal.
And that power isn't just in one number. It's across the entire spec sheet. The 5090 more than doubles the CUDA cores. It's got more and way faster VRAM, and this is a big one, it almost doubles the memory bandwidth. Just think of bandwidth as a highway for your data. The 5090's highway is just way wider and way, way faster.
Okay, specs on a sheet are one thing, but what does all that power actually feel like when you fire up a real AI application? How do these numbers translate to actual speed on the tasks you really care about?
And this, my friends, is where it gets really exciting. Look at this. For Stable Diffusion, the RTX 5090 is 3 times faster. 3! And if you're running a local language model like Llama 7B, it's churning out more than double the tokens per second. This isn't a small bump. This is a tangible, workflow-changing kind of speed increase.
And just to really drive this home, let's take a little trip back in time. Remember this quote from Bizon? Back in its day, the 3090 was the absolute king of the hill. It was the best consumer card you could possibly get for this kind of work. The fact that the 5090 just leaves it in the dust shows you how fast this field is moving. It's incredible.
Of course, raw performance isn't the whole story, is it? A GPU doesn't exist in a vacuum. You've got to think about the practical, real-world costs of actually getting this thing into your machine and running it.
So here's the reality check. The 5090 demands a massive 575 watts. That means you're almost certainly going to need a 1,000-watt power supply, maybe more. And yeah, the price reflects its top-tier performance. The 3090, on the other hand, is way more modest in both its power draw and its price. But here's a fun little surprise. The much more powerful 5090 is actually a smaller 2-slot card, which might make it an easier fit in some builds.
And it's super important to know the limitations. No card is perfect.
For instance, the 5090 doesn't have NVLink support. That means you can't physically bridge two cards together to pool their VRAM, which is something the 3090 could do. It also doesn't support MIG, which lets you split the card into virtual GPUs. And remember, at the end of the day, these are still consumer cards. They're amazing for building and experimenting, but they're not data center GPUs designed for training giant models from scratch.
Now we're really just scratching the surface here today. If you want to go even deeper, check out more benchmarks and see how these cards stack up against a bunch of others. The full deep dive is available from the source, bestgpusforai.com, and of course, we've dropped a link for you down in the description.
All right, we've gone through the tech, the insane performance numbers, and the practical realities. Now, let's bring it all home and give you a simple framework for making your final choice.
It really just boils down to asking yourself these 3 simple questions. First, what are you actually doing? If you're experimenting, fine-tuning smaller models, the 3090 is a fantastic, super cost-effective choice. But if you are trying to push the absolute limits of generative AI, you're going to want the speed of the 5090. Second, what's your budget? Is that 2 to 3x speed boost worth the extra cash? And finally, check your system. Do you have the power supply and the case to handle whichever card you choose?
You know, when you take a step back, the sheer amount of power we now have access to in a consumer GPU is just astonishing. The fact that we can even have this conversation, comparing these two incredible cards for our own personal projects, just shows how far things have come. And that really leads to the most exciting question of all. With this kind of power at your fingertips, what are you going to build next?